Hello everyone. So today we are going to cover an example for modulo inverse which we learned in the previous video. Okay, so we'll use the modulo arithmetic concepts for this example. So what the example says that you are given a string S containing one or more words. Every consecutive pair of words is separated by a single space. So A, B, C, and D, F, E, this is separated by a single space. I like that. Now, a string T is an anagram of string S if the ith word of T is a permutation of the ith word of S. So, let's say this is the first word of S and this is the first word of T. This is ACB and this is ABC. These are anagrams. Anagrams means the permutation of the words should be same. One times C should be here. One times B should be here. The frequency of each character should be same. And then you can arrange them in any way you want. Okay, ACB you can represent ABC, BAC, BCA, anything you can do. Like DFE and DEF. These are anagrams. But DEF and ADC, this is not, because here there is E character one time and F character one time, but here there is no E, no F. Rather than that, it's A and C. So this is not a anagram of this particular string. So we have to return the number of distinct anagrams of S which can be made out of the particular string S given to you. And that answer could be very large. So we have to return it modulo 10 raised to 9 plus 7. This is 10 raised to 9 plus 7. Okay, so basically let's say this is the example. You will be given with the string. I'll take this only. Here it's given to hot. Okay, so for the word to, how what are the different anagrams which you can make for the word to? First it should be double OT, OTO, and then OT again came, OTO came. Anything else? This to itself could be one of this anagram. Anything else which you can make out of it? No. So how many different permutations? How many different permutations you can make? If you know this, then the answer is the coding part is then very simple because we already learned how to calculate the modulo arithmetic or modulo inverse of the particular thing. Okay. For the hot, it's hot, TOH, OHT, HTO, then THO, okay, THO, TOH, HOT, HTO, OHT, OTH. Anything else? No. So these are how many? These are how many? There are three different characters which we can place at any 3 points. So actually this is 3 factorial, which is 3 into 2, which is 6. Right. These are 3 factorial. But this is also 3. Then is this 3 factorial? No. This is not 3 factorial because O is repeated twice. Okay. So any placement of O, this OTO could be another time also return as OTO, but then it's not the distinct word, it's the same word. So what we have to do, what are we doing at the initial stages? If you have learned in your school maths for this type of thing, what we do, we divide it by the number of frequencies. Okay, so if its frequency is greater than 1, so here T's frequency is 1, O's frequency is 2. Okay, then what we do, 3 factorial divided by 2 factorial. So this is 3 into 2 divided by 2, this is 3. So total 3 different permutations we can get, which is correct. And here no one's frequency is greater than 1, so we won't divide anything below this 3 factorial. So there are total 3 factorial unique permutations we can make out of this hot. So I hope you're clear with this. Okay, so how many different permutations? Different permutations. You can make is size of this string factorial divided by frequency of each character which is greater than 1 and that much factorial, however is the frequency. Okay, so now your step 1 is calculate factorial in advance, because if you will try to find the factorial when you are in the code, so let's say 3 factorial, so then you'll do 3 into 2, so then that will increase the time complexity. So calculate factorial in advance and store it in a variable, store it in a vector or something. store it in a vector. So factorial of 0 is 1. Then from factorial of 1 is factorial of I minus 1 into I, right? And so on. This way you will calculate until n. Until n, whatever is the maximum size of string which you can get from your question, okay, by seeing the constraints. Now what is the second step? Separate the strings with the separate strings with space. So they have given that strings are space separated, like 2 and then space and then hot, okay. So you first came for this 2, so you store each word, I could say, in a separate string and make vector of strings. Okay, make vector of strings wherein you will store each word separately. So let's say you have this vector as v. So v of 0 is 2 and v of 1 is hot. Okay, this way you have to do. Now, third step. Step 3 is for each word in string, calculate frequency of each character and find answer. What is the answer? Answer plus equal to length of the word factorial. Factorial you have already calculated on the top, right? Divided by uh, frequency of character greater than 1. That much factorial for each of these characters whose frequency is greater than 1. And that you can do additions. Okay, that you can do additions. So these are the total number of permutations, total number of anagrams you can make. Okay, so let's say for this 2 hot, okay, you have to make this hot as it is, and this you have to do is like 2 hot, this is 1, OTO hot, and another one is double OT hot. So 3 for this 2 and then 6 for this hot. Same way you will keep this 2 as it is and 6 different anagrams of this hot only. So with 2 same and 6 different anagrams of this hot you have to prepare. Okay, so this way your answer will be calculated. Okay, I hope you got the concept. So without wasting time, let's just solve the question. And you know how to calculate the uh, power, and also, sorry, this could be multiplied. Okay, this could be multiplied, that 2 hot, and this the same thing you have done, and for this hot also you have to do the same thing. So there are total 6 into 3, which is 18 different ways, 18 anagrams you can make of the string. Okay, 18 different anagrams you can make. Okay, any combination of this and any combination of this. So this is multiplication, not addition. So here your answer will be answer multiply equal to these things, and whole modulo m you have to take into care. Okay, let's solve it. Fine. So our first task is to calculate the factorial. Okay. So, okay, let's take how much. Okay, there are 10 raised to 5 maximum length with there could be. So I could make the factorial of length, let's say 10 raised to 5 plus 5. Okay. And anything else which I need to prepare for this? 10 raised to 5 plus 5 for this. And anything else which we would need while calculating this? Inverse, right? Inverse we will also store for each of those thing. For each of those we will store the inverse. Is it right? No, we won't store the inverse of each of them. We will just call it as it is. So inverse wouldn't be needed to store. Okay. So we have considered n as 1e5 plus 5, 1e5 plus 4. So that's why I made a vector of 1e5 plus 5. And we will be given m of 1e9 plus 7, which is our modulo. Okay. Now we have void calculate factorial. Okay. And we will store this factorial of 0 as 1, and then for int I is equal to 1, I less than equal to n, I plus plus factorial of I is equal to factorial of I minus 1 into 1 ll. Why 1 ll? Because while multiplying it could go beyond n raised to 9, beyond a integer range. Multiply by I whole modulo m. Okay, fine. Now this n is s dot size. We will have one vector of string which will store all the words. Okay. Now for int I is 0, or what I could do is I could have one I is 0 and a string temp also. Okay, which is initially nothing but empty string. Now while this I is less than n, if s of I is not equal to empty space, then what I have to do, I have to just add on this s of I under this temp string. So I'm building this word now. Okay, else means I have got s of I as empty as an empty string. So that's mean I've got one word. So if my word is not empty, then only I will push back it under my words array. So I'll push back this temp string under my word and I'll make it empty again now for another word to build on. And every time we have to do I plus plus. After moving out also, if your temp is not empty, then you have got another word. So we'll push this temp word under my words dot pushback. Okay, so now I've got my vector of string words. So now that I've got all words to heart like that. Okay, so now I have to traverse under each word. So I 0 I less than words dot size I plus plus. Okay, now for each of the word I have to make a frequency array, right, of size 26. Correct. For each of the word I need to calculate the frequency of each character coming under that. And my length is words of I dot size, is my length of the particular word, right? Words of I dot size. Okay, we'll have an answer here, uh, which is initially 1. Okay, now what I have to do, I have to traverse under this word. So for int j is equal to 0, j less than n, which is words I dot size, j plus plus. I'll calculate the frequency. So frequency of uh, words ij minus a plus plus. So this way I have calculated the frequency. Now I will traverse the loop of 26. So for int again j is equal to 0, j less than 26, j plus plus. My initial answer is now what? Answer is equal to factorial of factorial of length modulo m. Anyways, it will be modulo m only. So still, but let's put it as factorial of length modulo m. Okay, that's your answer. Now, if I feel that frequency of j is greater than 1, then what I have to do? I need to find the mod inverse, which is mod inverse of which number? Frequency of j. I'll pass m minus 2. No need of this. I just have to pass the mod inverse of frequency of j. We will write the function of mod inverse. And then what you have to do is, okay, your answer plus equal to, okay, no, your answer multiply equal to this answer, or let me write it in this way. Answer is equal to answer modulo m multiply by mod inverse modulo m whole modulo m, because this mod inverse anyways you have to multiply it. So we have seen yesterday a divided by b whole modulo m is a modulo m multiply by b inverse modulo m. So this is b inverse only modulo m. So this you will multiply in your this particular thing, right? Okay, and this couldn't be the answer. Whenever you are here, you will have one temporary answer, which is 1, and that temporary answer you will calculate over here. And after you have calculated your temporary answer with all these frequencies and all this done, so after you come out of this j loop, under the I loop you have calculated for all the words I, okay, that you will multiply with your original answer, whole modulo m. While while multiplying, it's better to multiply with 1 ll because it might go outside the integers range sometimes. Okay, now our main part left is to find the mod inverse. So okay, so we have one. Okay, sorry, mod inverse of any variable int where. Okay, it's nothing but return power function or calculate power function for variable by passing m minus 2 and this m. This m is also not needed because we have made it constant only. Fine, let's have a calculate power method also. So we could have int calculate power int a int, or let's put it int variable int m int a int m, and okay, that's the two thing only. But rather than putting it m, let's put me b. Okay, what you have to do, you have to find a raised to b only now, a raised to b. Okay, so for power we have yesterday seen the recursive method. We could write that in the iterative method also. Okay, so for iterative method, let's have a answer as 1 initially, and while this a is greater than 0, no, not a, this power is greater than 0, we are dividing the power every time. If you remembered, we are dividing the power every time. So if your power is odd, so if b and 1, if your power is odd, your answer is equal to answer, you will multiply the answer by a times, one times you have to multiply it with the num, which is a. So let's multiply it over here only. And now what you have to do is, you have to divide it by 2. But before doing that, you have to do x is equal to x into x, or sorry, a is equal to a into a, right? So I'll do a is equal to a into a modulo m, and I'll do b divide equal to 1. So b right shift equal to 1 is the same meaning as b divided by 2 in the, but this is still faster operation. Okay, and we'll return answer. Okay, I hope you are good with this. Okay, so this way, this is the iterative method for finding the modulo power. Okay, okay, we are done. Let's see. And finally, we will return what? The answer. There could be some errors, but we have calculated in okay, so initially we need to call this also void calculate factorial. Okay, so we'll write calculate factorial. We will call calculate factorial, then only factorial of length will be uh will we get. Okay, oh wow, so I hope you got it. Okay. For this type of questions, which are actually hard under this modulo kind of questions, this could be the modulo inverse of not just frequency of j, it's 2 factorials inverse. So it's the factorial of frequency of j, which we have to do it while calculating the modulo inverse. Okay, let's check again and submit it. Okay, because 2 factorial is 2, and again 2 factorial is 2 only, so that's why it didn't came the issue for the test cases. But we have to do the inverse of the frequencies factorial, not just frequency. I hope you got. Now this type of questions could be solved easily once you learned how to find the modulo inverse and how to play with it. Okay, so this is the only use case of it for solving this complex type of problems. Stay tuned for the next video wherein I'll be going to cover the sieve of Eratosthenes theory and we'll solve the problems regarding that. Stay tuned, stay safe until that. Bye bye.